Hello. I'm going to give a short talk, so like 10 minutes, so don't worry about it. It's going to be about Stringer. Now, some of you might not know about Stringer. There's a little too low. I don't know how this works. I forgot about this. I prepared a little quiz first. So take a minute to read this piece of code. And in a minute, I'm going to ask you which answer you think is correct. Is that big enough?
Yeah, maybe.
So for those who are not familiar with the template package, this what it does is it uses a map, iterates over it, and then does something to print something. So the question is, what does it print? Are you guys ready? Okay, so show of hands for 0. Show of hands for 1. Show of hands for 2. Show of hands for other. Okay, so who said 2? Because I saw like 3 hands. Yeah, you're correct. The reason is kind of fucked up. Oh, sorry, too many beers. The reason is, when you iterate over something in a template, it always does elements, always. So if it's array, it does the element. If it's slice, it does the element. But if it's a map, what's the element? Apparently it's the value, not the key. So if you want to get the key, you have to do $key, $, and that's going to give you the key. If you do that, it's going to do something stupid. So don't do that. Okay, on to the talk. So you guys all know about methods, right? And you guys are probably familiar with the string method. It's a string that it's a method that stringifies something, some object. In this case, for example, we might have an enum-like type, let's call it pill, and then multiple values it can take. And then if you stringify it, it gives you the name as a string, right? This is simple. Then how would you implement this? Manually, you would do something like this. Or maybe you would use a map, or you would use an array, but it's pretty much the same idea, just boilerplate code. And that's why somebody wrote a tool called Stringer way back. And what it does is you give it a type that's enum-like in this kind. And then it gives you an implementation of this string method. And it generates a file for it, a Go file. And you may use a Go generate line for this, which makes it easier to generate. And then the output that, for example, that thing generates nowadays, it's that. And it may seem complex, but it's actually pretty simple. It doesn't use a map, it doesn't use a switch, it does something slightly clever. What it does is, it puts all the data in one single string, and then it slices into that string in a sort of clever way. If you look at the index array, what it does is, for example, between 0 and 7 is the first string, between 7 and 14 is the second, and between 14 and 23 is the third. So then it can slice directly into the single string. And the reason why it uses a single string is because if you have, for example, 1,000 values, putting 1,000 strings into a binary usually takes up more space than a single string, because this doesn't have to worry about padding, doesn't have to worry about giving the compiler more work and that sort of thing. And it also does stuff like, for example, using an array. An array has a compile time length. So then the compiler, if you use, for example, a constant as a pill, then it would know, for example, which branch to take in the body, because it can know whether or not that if would be true or not. And it also has a fallback. If you give it a value that's not one of the 3 values that it knows about, it's going to do something, it's going to have a fallback, which is pill, and then between parentheses the actual value. So it's kind of useful. And people have been using it for quite a while. It came out in like 2011 or something like that. But it has some limitations. For example, suppose that you have that type, but you want the strings to be different than the actual names. Because, for example, suppose that you're using a prefix for the actual names, because there might be multiple reasons for that. One of them might be maybe your package has lots of exported names, and you want the names to be neatly organized depending on what type they are. So until now, you couldn't really use the tool. But what we did is a feature was added where you can now give it a prefix, and it trims that prefix from the strings that it generates. Another one, I kind of like this one. It's simple, but it's powerful. Suppose that you have ones where the actual value that you want as the string is not a valid identifier, a valid name in Go code, such as, for example, tokens. If you have a plus or a minus, you cannot use those as constant names because they're not names, they're operators. So then with this option, with this flag, what it does is if there's any line comment, as in any comment in the same line at the end, it uses that as the value, and if there's nothing, it just does what it would usually do. And the last enhancement that I did recently is a little bit more difficult to explain. So the one at the top is what it did before, what it did last year, and the one at the bottom is what it does now. Can anybody tell me why this is good, why this is better? If it's not obvious, the difference is that before it used the FMT package, and now it uses the strconv package, however you pronounce it.
Does it inline the call?
I don't know if inlining is involved, but it's not the main reason.
Is %d going to grid?
Sorry, what?
Is %d, is that
I think the two are equivalent because at the bottom you also do 32-bit, you do format end.
Fewer memory allocations?
No, it's not got to do anything with optimizations. Yeah?
So I was going to say, FMT tends to use syscalls, line whereas with FX, it's like
No. So yeah, FMT is likely going to be slower here, but the actual reason is you pull in more dependencies if you import FMT than if you import strconv. If you think about it, strconv is a much lower level package. When you import FMT and you do stuff like formats, under the hood, if you give it %d, it's going to use strconv under the hood to convert that into a number. So it's more like a lower level version of it, of the same program. But the reason why this is actually useful is because the standard library itself has levels of libraries, levels of packages. So for example, if you're the package math, you cannot import the package log, because if you did that, you would introduce a circular dependency. The slides are going to be uploaded later, don't worry about it. But the reason is because they define what are like very basic packages, then another level of basic packages, and so on, so that they can ensure that like the dependencies only go outward, not inward, because otherwise they would run into import cycles all the time. So what's important here, what's interesting here is that FMT is in level 4. It's the last level because FMT is a monster. It may not seem like it, but it can do padding. It can print structs. It can print interfaces. It can print fucking everything. Sorry. Yeah, it is a good term. So the problem is that if you make the generated code import FMT, then all the packages in levels 1, 2, and 3 cannot use stringer, because if they do that, they're likely gonna introduce an import cycle. But by using strconv, which is in level 1, then the only packages that cannot use it are the very, very basic ones like runtime or IO, and those are like just a handful, so it's fine. So that's the whole reason. And it wasn't me who proposed these changes, but somebody else did, and I tried to implement them, and neither of them got accepted. So this might be a little lesson in your changes are not always going to be accepted, especially in Go itself, because people are very opinionated, which is a good thing. The first one was detecting prefixes automatically. So you have lots of names and they share a prefix. So you could avoid specifying the prefix. You could just tell the tool, figure it out. But as it turns out, figuring out a prefix is kind of a little bit of spaghetti code because it's a nasty algorithm that just does a quadratic search. And secondly, you only ever write that line with the prefix flag once, so there's not really much of a point in automating it, so bad idea. The code goes down the drain. The second idea was what Stringer does is it looks for a type in the first format that I showed there, but it doesn't work with the second. The second, what it does is, it doesn't put a type in the declaration expression, but it puts a type on the right side. So it basically makes the compiler infer the type instead of just giving it directly. And somebody else proposed to accept both, and I implemented it. It was fairly simple. But then somebody basically said, why not rewrite the second as the first? There's no reason not to. And again, you're only going to have to do it once. So why add 50 lines of spaghetti code to do something that is not really necessary? So nope. And that's pretty much it. Those are all the substantial changes happening in the last year in this little tool, but they might be useful to you. And even though it's a kind of small tool, it's very interesting. So I suggest you check it out. Any questions? Yeah?
It's just written by string was written by Ron Pike. So that's the guy.
Yeah, he was also the guy that said no to my patches.
Have you seen E-number?
Have I seen what?
E-number. It's like another extension of Stringer. It adds like generated JSON marshalling and reverse int string lookups. Can you repeat the question?
Yeah, he's asking if I've heard of E-number, which apparently is a similar tool but does other things like going from string to int and doing other things like JSON marshalling or unmarshalling. I haven't heard of it. It rings a bell, so I should check it out. Thanks. Any other questions? Yeah?
Could you go back to the slides where you've got your struct but with comments in there, and I didn't quite follow it and why you didn't use that one. Go forward. Why you didn't use like some kind of struct tracks for that or not? Or did I miss?
I could have used
struct.
struct.
Sorry, that's why.
Oh yeah, that's a good point. Yeah. I totally wasn't going to answer that. Any other questions? Cool. Thank you.
Thank you.